If I put a flashlight in space, would it propel itself forward by shooting out light? It has been shown that light can impart a momentum on an electron that absorbs it, but it has not been shown that an electron has a recoil when it changes state and emits a photon. So the object, the flashlight, would move if you exposed it to external light, but if it is just generating its own light, it will not create a thrust. Don't know much about physics, but why would the weight of an object matter in space? Wouldn't any object be weightless? I would have thought that the surface area of the reflective, light-producing object would be what mattered. Can a physicist please explain? How do you measure movement in space? I always think about how you would test ops question. How would you set a flashlight in space without already being in motion? Or because it is all theoretical anyway, it doesn't matter. Quote closing square bracket. So in this same line of thinking, does this mean that we could set up a series of stationary satellites that could shoot powerful lasers at a spaceship or satellite as a form of propulsion? In this way, most of the weight issues would be stationary on the laser platform instead of on the ship. Single quote closing square bracket. What about the lens of the flashlight? The light from the bulb is going forward. Some of the light hits the reflector then bounces forward. Both of these streams must pass through the lens. What effect does this have? Okay. Can someone help me with this? I understand how the whole expansion of E equals mx squared expands to let light have momentum and energy, but when determining the force that the flashlight is being exerted to, does F equals ma expand to something similar? Since light doesn't have mass, would it technically have no force? I see what you're saying. So the force would be inertia?